positive or negative, the singular part, which fractional exponents, math becomes an art. We graphite it and find it, the slope and the score. Easier, and you're the reason we are
Hey guys,
for more.
I asked you to do this with me in this 4.37 simplify expressions rational exponents. And on the blue side, I just kind of wanted you to figure it out by kind of like, I don't know, just intuitive, just play with it. I kind of showed you. And on the pink side would be the law of exponents. Okay, so x squared means you have xx. And x to the fourth means you have xx, xx. Well, you can just count up all of your x's there. And you have x to the 6. So recall that when you multiply powers, the exponents are added. Added is what goes there in the blank. So x to the 2 plus 4, and 2 plus 4 is 6. Okay, so yeah, notice you have 2 plus 4, that gives you 6. Okay, now when you, on this side, we just has the quantity. So I have 3 of them, 1, 2, 3, so that's xx, 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 and there's still x to the 6. Well, how do I get that? When you raise a power to a power, there is a power to a power, or exponent to exponent. Exponents are multiplied. Multiplied. So that would be 2 times 3, which would give you the x to the 6th power. Okay, so you notice that these two I have here, what's the difference? That one you have 2 x's. This one, number 3, you have 2 x's, but you have 2 fractional exponents. Those are called rational exponents. That's what we've been learning. So you can add them because your denominators are the same. That's what you do in fractions. So I have 1 plus 3 over 2. So, number 3, ensure that the d, the denominator there in red, ensure that the denominator, which is the down part of the fraction, is the same. That's the only way you can add fractions. So notice I have a 2 there, they're the same, common denominator. So this would be x to the 4 over 2, and 4 over 2 can be reduced to just 2. Okay, so let's go ahead and go over here and try example A now. Let that focus. Okay, so now I have my denominators. I have a 3 and a 6, but they're not the same. So I have to have a common denominator. Well, if you think about this, I can just multiply this side by 1. And that red there is 1 is 2 over 2. You can multiply any number times 1 in math, and that's okay. So you can add across, or multiply across, sorry, so you have 4, 6, and 1, 6. So a common denominator is 6, so I get 4 plus 1. Now we can add those. So now you're going to get x to the 5, 6. Okay? Alright, let's try another example here. Let's go ahead and try B. Well, you should notice in B that right away you have a negative rational exponent. That negative sign is going to tell you to make it a fraction, put it over 1. So now think of it as you have a 2-story house here. And you have upstairs and downstairs. Upstairs is called the numerator, downstairs is the denominator. Okay, so negative tells you to go downstairs. But when you go downstairs here, you're going to eventually take off the negative. Okay, so here is a fraction line separates the upstairs and downstairs. And so now I have y to the 2/3. It's not switching them, but there is a 1 left. So I have 1 over y to the 2/3. Okay, so over here, y to the 2/3 means a fractional exponent or rational exponent has a radical sign. And in math, if there's a radical there, you can't have that. So you can have that, so that's why I wrote no there. In math, to get rid of that, we're going to do something called to rationalize the denominator. Rationalize the denominator. Okay, what that means is if I do a product, our goal is to get 1. 1 is the special number. 1 is the special number. Okay, so I'm going to take y to the 2/3 and I want it to multiply by something, y to the something power, so that it equals 1. And you're going to have to come up with that number. And that number is going to be, well, 2/3 plus something equals 3/3 or 1. That number is going to be 1/3. Y to the 1/3 over y to the 1/3. Remember that expression is equal to 1, and that's okay. So I get y to the 1/3 in the numerator and y to the 2/3 plus 1/3. Remember, you're multiplying the same base, you can add the exponents. So I have 2/3 plus 1/3, that'll give me y to the 3/3, and that's just y to the first. So let me bring up my paper here, give me a second. So now it's gonna, your answer is y to the 1/3 in the top, and on the denominator, y to the first power. And that'll help you get a product of 1. You have to come up with that number y to the 1/3. And so you add them together and it'll equal 1 right there. Alright, let's go ahead and try example C here. Notice I have the base is the same there. I had 2 z's on the bottom. We're multiplying. So what we're going to do here is we're eventually going to add the exponents. But in order to add them, the denominator, the down part, has to be the same. So I'm going to have to think of a number. Well, you can just count out here. 3, 6, 9, 12, 15, 18. And you count by 4s there. 4, 8, 12, 16. You'll notice there's a number in common. The lowest common multiple is 12. So the goal is to make both the denominators 12. Well, you have a hint here. multiply this side by 4 over 4. There in blue that I wrote. And then on this side, so let's multiply that out, negative 4 over 12, so it's an equivalent fraction. And on the other side, there's my hint, 3 over 3. Right, you can multiply any expression times 1 and it doesn't change it, so now we just multiply across and then we get 9/12. Okay, so now my denominators are the same. This is good news. So use the hint there. It's just on the other side. Most of the time it works. So now I'm going to do z to the negative 4 over 12 plus 9. Okay, I can add the tops. Let me zoom out here, give me a second. And then we'll get z to the 5/12 is our answer. Alright, let's try our last example here. Let's go down to D. If you compare C and D, this one has a fraction, this one has a decimal. So how are those related? Well, you could do something like what we did in C here, is just move that one up and you'll have a negative rational exponent. Alright, so let's go down here into C here. I'm going to move this one upstairs. Now, you could have moved either one, but you'll kind of see the ends. Looking back, you know, looking back at life in hindsight, what you would have done. So let's go ahead and move that one up there. Oops, off camera. Let's move up my paper. Okay, so if you move it up there, then you're working in the upstairs, the numerator, and now that, notice I have to add that negative sign now. Okay, to move it up, you have to add that negative there. Okay, so I don't know why I wrote 5 over 5. I should have wrote 5 over 5 on this side. That means on the left side, I should have 2 over 2. Let me change that, sorry. Okay, so you notice they're in yellow. Those are multiplying by 1. Changes the look of the expression, still equivalent. Let's multiply across, you're going to get z to the 8 over 10. And then z to the negative 5/10. Remember, you have the negative there, so you get like negative 1 times 5. Then same base, multiply on the same base, you can add the exponents there. So we're going to get an az. So now I'm going to add those. Or if you look back, we are multiplying, so we're just going to add those. So that'll become 8 minus 5, which give you z over z to the 3/10. Alright, example 44. X times x to the 1/3 times x to the 2/5. I have the same base, so we can add the exponents. But in fractions, you cannot add across. We need to have a common denominator. Most of the time, you could just multiply by that number. You get very close. So 15 is going to be close. So how do you get them to be 15? Well, there's my hint. I'm going to multiply this side by a number, and that's going to be 1. So this side I'll multiply by 5 over 5, right side 3 over 3. Okay, multiply across, you'll get 5 over 15 and 6 over 15. So they both have a common denominator. So I just add numerators. 5 plus 6 gives me 11. X to 11/15 is our answer. Alright, question number 45. We should recognize that we have here a negative. So automatically you should put it over 1. That's going to go downstairs. And I get 1 over b to 3/4. Notice that 3/4 doesn't have a negative sign anymore. Okay, so we want to get rid of that 3/4. Remember, it is a radical. Go ahead and talk to your partner about what you put in that little box right there. It's going to be b to the 1/4. Remember that expression here is 1. And if we add those together, we'll get 4 over 4. So on the top there we have b to the 1/4. And let's go ahead and add those. So we'll get b to the 1/4 over b. Alright, here, question number 46. Take a look here. Multiplying the same base, a, that's good. And let's see if I have a common denominator here. Or eventually just add across. Four nines plus 1/4. We should recognize though we cannot add across because my denominator is not the same. So we need to multiply this side by an equivalent fraction or get an equivalent fraction, and same sign with this one. So 9 and 4, so 9, 18, 27. But you can keep counting until you find a common number, but here's a trick. Put that number over there. So I'm going to put 9 over 9 over here. So I get 16 over 36. Just multiply across. You get 9 over 36. And now we have a common denominator of 36 here. Same base, we're going to add the exponents. So 16 plus 9 over 36. This will get me 25 over 36 as our answer. Alright, question number 47. Y to the negative 4/5. So we should recognize right away the negative exponent to put it over 1 to make it a fraction. So we know that there's a top and the bottom there. And the negative tells me to move it down. That's why I circled it and put it in green there. So let's go ahead and move that. And now the y to the 4/5 there. Notice that it is has no negative. Now we need to multiply by something here. It's going to be the same. It's going to be y to the something, so the 4/5 times something will equal what? Well, that's going to be 1/5. You have to come up with the 1/5 there. Okay, so if I multiply across, I get y to the 1/5. And on the denominator there, 4/5 plus the 1/5. 4 plus 1 is 5, so I get 5 over 5 is just 1, and my answer is going to be 1/5 over the y there. Notice there's no fractional exponent in the denominator, and you wouldn't cancel these y's because they're not the same expression. Like up here, this is what we want. I have a 4 there, that's good. Same base. You're multiplying, you add the exponents. 7 plus 5 gives me a 7 plus 5 over 4. And that'll give us 12 over 4, which you can reduce. Which reduces to a to the third power. Alright, number 49. Let's look at this. This only has one base, but two exponents. So let's go ahead and look it to the front and think about which number. Well, this is number 2. I have a power to a power, so we're going to multiply these. So b to the 3/4 times 1 over 3. Multiplying fractions, all you have to do is just multiply across. Multiply across. And if I multiply across here, I'll get 3 over 12, and then I can reduce this, divided by 3's, and you get b to the 1/4 power. Alright, question number 50, I have a negative exponent, so let's go ahead and quickly make that a fraction by putting it over 1. Okay, now the negative exponent is going to switch. So now it's going to go downstairs. So I have 1 over d to the 5th 5/6. Now we have to multiply it to get rid of that fractional exponent. So I'm going to have to multiply by some kind of number. And that number is d to the 1/6 over d to the 1/6. Because d 5/6 plus 1/6. Hold on a second, I'll move it down. That'll give me 6 over 6, which is d to the 1st. Right? 5 plus 1 is 6. 6 over 6 is equal to 1. So I get d to 1/6 over 1 is my correct answer. Alright, question number 51 here. Same base, let's multiply those. So if I'm multiplying the same base, then what do we do with the exponents? We add them. Okay, this is nice. They are common denominators. So you just add the tops. Let's go ahead and do that. So common denominator here in red, x over 3, x to the equals x to the 2 plus 8 is 10. So I get x to the 10 over 3. Let me bring this down. Give me a second. Alright, question number 52. You'll recognize there's only one base, but there are two exponents, so that is a power to a power. So we actually just multiply those. -3/5 times -1/4. Unlike addition, you don't have to have a denominator be the same, so you can just multiply across. Let's go ahead and multiply across in our problems. Multiply across. So negative times a negative is a positive. I'm going to get 3/20. And that's our answer. Alright, question 53, negative exponents, put it over 1. Now I'm going to deal with the negative exponents, going to go downstairs here, so w to 7/8 is in the denominator, and there's something left in the top of the fraction, that's a 1. 1 over 7/8. Haha, don't forget, due date's coming up. Okay, so we have to multiply by some number to get rid of that 7/8, which is basically a radical. So that number will be 1/8. You have to come up with that number. W over 1/8 over W 1/8 is 1. It's legal in math to multiply it by 1. So I'm going to get W to the 1/8. And then you add across 7 plus 1, so the number is 8. And so your answer is W to the 1/8 over W. Alright, question 54. We have a fractional here. And I want to get them together. So maybe we move this. You can move that one up. Or, let's see what happens if we do that. Or if it goes up, we're going to have to do what with our fraction there? We're going to have to make it a negative. So c to the 2/3 and then c to the -1/6. Okay, we move it up. In this case, it's going to be a negative. Okay, so now same base, we're just going to add the exponents here. So I want the denominators to be the same, so I'm going to multiply here by 1, which is just 2 over 2. And so basically an equivalent fraction, you multiply across, it's going to be 4/6. So c to the 4/6 minus a plus a negative 1/6. It'll essentially be 4 plus -1 or 4 minus 1, which will be 3/6, and we divide it by 3, so I get c to the 1/2 is my answer. Alright, question number 55. We got a lot of stuff going on right here. I'm first going to bring this one. Okay, so what I'm doing here is putting them all together, like all the kids play a game in the house. So I have 1 left in the numerator. That just comes with there's nothing up there, so it's not like they all go from downstairs to upstairs. Now they're all downstairs. 4f 1/2, f to the -1/3, f to the 1/4. Okay, so notice the negative sign is now gone. Okay, now I have all the same base of an f, so I'm trying to figure out, well, what's the common denominator? So you can just multiply these out, all your multiples, 2, 4, 6, 8, 10, 12, 14, 3, 6, 9, 12, 15, and then count by 4s, 4, 8, 12, 16. Well, what's the lowest common multiple they have there? That'd be 12, so I want to make those all 12. Let's go ahead and do that. So that one will be 6/6, so that'll give me 6/12. Now I'm going to multiply by 4, so that would become f to the negative 4 twelfths. And then f, I'm going to multiply this one by 3 over 3, so that would become my positive 3 twelfths. Okay, so they all have the common denominator, so let's go ahead. I have 1 over 4, 6 minus 4, plus 3 will give me 2 plus 3 is 5, so I get f to the 5 twelfths. Okay, pretty good. Now I can't leave that rational or fractional exponent there, so I'm going to have to multiply by a number to get rid of it, right? Because that's basically a radical. We can't have radicals there. So I'm going to multiply by something. Same thing up here. That same expression. You have to think of this. So 5 plus something, that'll be a 7. 7 over 12. 7 over 12. Let's go ahead and simplify that. So now I have f to the 7 twelfths. And denominator of 4. Then 5 plus 7 is 12. And 12 over 12 is just 4f. That's just going to be 12 over 12, which is 1. And that's your answer. And let's box it. And don't think you can simplify the f's. You can't cancel them. No. Alright, number 56 here. I have the same base. They're all y's, which is good. We're multiplying, so now we can add the exponents. So I'm just writing out all the multiples or factors of 4. 4, 8, 12, 16, 20, 24, 28. Let's do 7. 7, 14, 21, 28, 35, and 28. Well, if you guys look through the 3 lists, what is our lowest common multiple? The answer is 28. So I need to somehow make all of these a denominator of 28. Well, it gives us some hints here. I'm going to multiply this one by 7 over 7. And change colors here. That one, there's my hint, 4 over 4. So that'll become 12 over 28. 1 times 7 is 7 over 28, and then 19 over 28. So if I go ahead and add all those together, I'm going to get 38 over 28, just divided by 2, and you get y to the 19 over 14. Kind of just leave it like that for now. Question number 57 here, I drew this weird fraction line there in blue. And you have a missing number there, so it's really just x to the first, those two are on the top. So let's all get them together. So I'm going to move this up. If I move it up, then that's going to become a negative exponent. X to the negative 5, 6. X times x to the 1, 6. And then the red we just did there was x to the negative 1 now. So it has a negative because it moved up. Well, I want to make that a fraction. So let's put it over 1. Now, if you look at the other fractions, you'll notice something. They all have something in the denominator. That's 6's. So x to the negative 5, that's a positive 1, and that one's a negative 6, all over 6. Okay, so I have negative 5 plus 1 is negative 4, negative 4 minus 6 is negative 10. Negative 10, 6. So here you're going to do a couple of things. You got to get rid of the negative. And you might need to reduce the fraction. So they're both even. You can divide by 2 there. And we will get x to the negative 5 thirds. Okay, let's take care of the negative. Just put it over 1. That's going to go downstairs. So we have the answer of 1 over, and then the x to the negative 5/3 comes downstairs, but you get rid of the negative, so it'll just become x to the 5/3. Box it. That's your answer. Alright, 58, I got c's on my bases. That's good. So now we can add the exponents. 4 lemons plus 2/3 plus 34 over 33. Well, I want them all to have the same number on the bottom there. So fractions lessons, we can change them by getting equivalent fractions or multiplying them by 1. So I want them to be 33. How do I get them all to be 33? Well, there's some hints. Take a look at those numbers. You can just multiply those numbers. There's a hint. I can use the 11 and the 3. So let's circle this. That's my hint. Let's multiply this other fraction by 3 over 3. Look at that. Now let's multiply this side by 11 over 11. Okay, I did that, so I can get all my denominators to be 33. Okay, so now we get 12 over 33. This one will be 22 over 33. And that one will be 34 over 33. So now, again, we're adding because the bases are multiplying. So we just add all of those up. You're going to get c all over 33. So 12 plus 22 plus 34. And we're going to get 68. 68 over 33. Box my answers. 59, I drew this weird fraction, and I'm going to move that a up. So a to the negative 5 ninths times a to the 4 ninths, and then a to the negative 1. The negative 1 allows me to move it up. Let's go ahead and make that a fraction here. I want them all to be 9s, but before I do that, I'm just going to do over 1. And in math, it's okay to multiply by 9 over 9, because 9 over 9 is 1. So I have a to the negative 5 plus 4 minus 9 all over 9. Okay. Now we can add, because all the denominators are the same, a to the negative 10 ninths. Okay, can't have a negative here. So let's just put it over 1. Move it all downstairs. Remember, the temptation is you think the answer is a to 10 ninths, but you had something left in the upstairs, so you're going to put it 1 over. Okay, and there's my answer. Box it.
You don't want no math and eng, you don't want none. And if you want some math and eng, come in. Get some, say what? Come in. Get some, say what?